Hi and welcome back to the channel. This video is going to be about ImageMM and the Live Stacker in KStars. So, as some of you might be aware, a paper was produced back in the tail end of September by some professional astronomers / mathematicians, computer scientists, who were looking to try and get the best out of some of the more recent professional telescopes that are coming online, like for example the Vera Rubin. So they have developed a new method of stacking, primarily aimed at, as I say, telescopes like the Vera Rubin. Some of you may have noticed on the astronomy forums that this has been picked up by some of the amateur astronomy folks. And there have been some discussions about how suitable or otherwise this might be for amateurs to use as an alternative to the more regular stacking approach. So I thought it would be kind of fun to see how this might work in a live stacking environment. So what's it all about? If we go to the paper that the folks produced, so I think they're associated with Johns Hopkins University in Baltimore, but there's a few other institutions in the credits, so it's probably a collaboration with other folks as well. I'll put a link to the paper in the video description, so anyone who's interested can obviously go and have a look at that if you haven't already. I'm not going to go through the paper other than probably just to say one thing. So this is the kind of the guts of what this stacking method is about. So what they're assuming is that there's an image before it gets convolved with the atmosphere and any imperfections in your telescope, etc., which they're calling Y here, and they're saying that for each of the subs, that particular image that we would never see, because obviously we're ground based, but this will be the image coming from the object before it goes through the atmosphere. That image Y is the convolution of the image we actually see, X, with a PSF that represents the atmosphere, our telescope imperfections, etc., plus some noise term. So for those of you that may be familiar with this type of equation, this is very similar to a deconvolution or a convolution type equation that we've probably all tried to use. So you typically would take your stacked image, you'd deconvolve it to reveal more detail with a PSF, and if you play around with the PSF you get a better or a not so good image, etc. So what these folks have done with this paper is they've kind of used that approach, but as opposed to doing it on the stacked image, they're doing it on all of the subs, and they're then using some iterative process to give you the most likely what they call latent image, or this is the Y in this equation, the most likely latent image that would generate all of the subs that you observe on your sensor. And the maths behind it is obviously in the paper. The MM comes from the approach they've used, which is majorization minimization, hence the MM part. And they've tested this out in the paper on a number of images from professional ground-based telescopes with some quite good results. One of the things they make clear in the paper, though, is that it's extremely resource intensive, and they have methods to use GPUs to get the most out of the process. So I'm not going to say anything more about the paper. As I mentioned earlier, I'll put a link to it in the video description, so anyone who's interested can take a look. So going back to the KStars Live Stacker, there is a new stacking method called ImageMM, and you have associated with that some fields. Because this is an iterative process, and because the iterations are going over all of the subs that you specify, it is extremely resource intensive. So this won't be suitable for anyone running a low powered machine. So if you're struggling on standard live stacking, for example, then you're not going to get anywhere with this with this new algorithm, because it is resource intensive, both in terms of CPU and its memory usage. So if, however, you do have a reasonably powered machine, then it might be worth giving it a go. So I'll give it a go on some of my sub data that I have. So let's just pick some data. This is obviously the Crescent Nebula. This, by the way, is the just a standard stack using the sort of standard stacking approach. So we can compare the results of the ImageMM algorithm with just standard stacking. So you have to specify a number of iterations. Now, the more iterations you specify, the better the result will be, but also the more resources that will take. So I've set it to 3 here. I wouldn't go much above that on my machine. I will downscale the image because, again, this is very resource intensive. So a way to make it run faster is to downscale it. Now these other variables, kappa, alpha, and the sigma scale, you can play around with. They essentially control the algorithm a bit and let you really make it, either soften the algorithm or make it more aggressive. I think, as with most things that involve deconvolution, if you overdo it, you'll see ringing around stars, and the image will look a little bit plastic. So it's fairly obvious if you've overdone it. So I'm going to just pick some numbers that I know are reasonable. Kappa of 1.2, alpha and sigma scales of 0.9. There's also an option here to update the PSF iteratively as the algorithm goes. I've been finding that's a bit aggressive, so I probably need to down tune that a little bit. But anyway, I'm going to turn it off, which you do by just setting this to 0. So there is some help on kind of what these parameters do. So you can obviously play around with them and keep stacking them. But anyway, I'll let this run. So it'll do the usual thing. Read in however many subs you've specified here, do a stack, read in some more, do another stack. Slightly different processing for the ImageMM, in that it also looks back at a number of subs again. So it looks forward by 3 subs in this case, and it also holds a buffer of the last 3 subs it's processed. So it is holding more in memory, so it is going to be more resource intensive. So that's the result. If I zoom in, and kind of have a look at it. Zoom this one in for comparison. So you can see this I've probably been a little bit too aggressive in some of these parameters. You can start to see a little bit of ringing, but you can see, I don't know if you can see it on the video, but it's possibly slightly more detail, but quite a bit more noise in the ImageMM version. Now you can tune that out by playing with these parameters. Obviously, the more you tune out, you're tuning out both the noise and the detail, the finer detail. So it's obviously always going to be a compromise as to what you think is best. But anyway, it's worthwhile having a play around. I would say it's very much sort of a beta at the moment, and there's probably a bit more tuning I need to do on it. But obviously, if anyone's has a go with it and has any feedback, please let me know.